All right, this is going to be our kickoff on fractions, and I kind of am introducing the fact that I know that most people struggle with fractions, and that they seem to be sort of the source of difficulty for most elementary, middle school, high school, college, no matter your age. Fractions are confusing. And one of the things that will help make fractions more approachable and easier to understand is realizing that everything involving fractions is no different than what we've already learned about addition and subtraction and multiplication and division of whole numbers and of integers. So if they really are no different, then we should be able to do everything that we do with whole numbers and integers on a number line. The same with fractions. We should be able to work with fractions on the number line. And as a matter of fact, fractions exist. They live on the number line, just like whole numbers. On our typical number line, each one of these ticks is a different whole number. We go from 0 to 1 to 2 to 3 to 4 and so on. And the space between each mark is represented as a unit of 1. From 1 to 2, from 4 to 5, each space is a unit of 1. When we begin to get to fractions, we get into subdividing the number line. That's all. So for example, let's subdivide each unit of 1 into 3 little parts. So now each one of these parts is a third of 1. And we're going to look at how that works with a fraction. When we write a fraction out, the denominator simply is telling us how many equal parts to divide our unit in. And on the number line, and whenever we're dealing with fractions, we're talking about a unit of 1. When we just say 1/3, we simply mean the denominator, is how many parts we're subdividing each unit of 1 into. So since our denominator is 3 here, each one of these, the distance from here to here, the distance from here to here, between any two marks is now 1/3. Now our numerator tells us how many of those marks that we're talking about. So if we say 1/3, we mean here. That's the distance of 1/3. If we say 2/3, then we're talking about 2 of them. So that distance, there's 1, there's 2. Just like with whole numbers, when we say 2, we're talking about 2 units of 1. With fractions, when we say 2/3, we're talking about 2 units that are each length of 1/3. So our numerator is the number of segments, and our denominator is how many equal parts each unit on the number line is subdivided. So when we write the fraction as AB, the top number, A, is called the numerator, and the bottom number, B, is called the denominator. So some examples of like when this happens. It's important to put this in context. And a good example, a yard is 3 feet. So on the number line, if each one of these marks represents 1 yard, then we have 1 yard, 2 yards, 3 yards, 4 yards. But if we need to subdivide with feet, we can say, okay, well now let's divide each yard into 3 equal parts. So now each one of these distances is a third of a yard, which is the same thing as 1 foot, because 3 feet make up a yard. An example of this, in football, I'm going back here, we typically measure in yards. Each line on the football field represents 1 yard. However, when the referees are measuring to see if someone got a first down, their ruler actually subdivides the way we have it drawn here, because when you're getting if it's a really close play, they need to get within feet to be more accurate. Another example is if a hat manufacturer sells hats with five hats per box. If they sell 36 hats, if we draw that on a number line, each one of these marks represents a box or 5 hats. However, once we get to 7, we've gotten 35 hats. There's 1 more hat. So we need to subdivide to show how many actual hats there are in each box. So we're dividing our number line where each unit is divided into 5 equal parts. Another example is on a measuring cup. If each one of these marks represents a quart, and we have a recipe that calls for 2 quarts and 2 cups, so we're going to need to subdivide this number line. So we get 2 quarts, and then, hey, there's 4 cups in a quart. So we need to subdivide each quart into 4 equal parts, so each one of them represents a cup. It's also important to sort of demystify the idea of an improper fraction. We may remember an improper fraction is a number where the numerator is bigger than the denominator. It's still a fraction. There's no difference between an improper fraction and a proper fraction when it comes to understanding where it exists on the number line. 1/3 represents one of these parts. 8/3, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That's where 8/3 is. And we could keep counting up 9, 10, 11, 12, 13, 14. That's where 14/3 is. When it comes to working with fractions, whether or not it's proper or improper has no impact on how fractions work or what value they represent. So this is a nice problem where I'm just kind of asking you to drag some of these over here. You can see we're in fourths, so 1, 2, 3, 4, 5. That must be 5/4. We can look here and say, hey, there's 2/4, and we would continue on with that in class. Now, when a unit is divided into b equal parts, 1 over b is going to represent one part, and a over b is a of those 1 over b parts. And we kind of just said that. So here's some examples just to look at, and we're leading up to a point that's pretty important. I want you to notice that each whole number, the numerator is a multiple of the denominator. 1 represents 3 of 3 parts, which I think kind of makes sense. If we divide it into parts of 3, there's 1, 2, 3. That's all those 3 parts. We're back to just a whole number. And then if we have another 3, we're going to be at 6 over 3. And another 3, we're going to be at 9 over 3. So in class, I would ask you to place all of these on a number line. So what we were saying just a second ago about multiples is kind of the beginning of some of these properties. And the first identity property of fractions is that a over 1 equals a. So when we subdivide our number line into units of 1, well, that's just whole numbers, right? So if I say 3 over 1, I just mean 3 units of 1, which is what we call 3. There's no need to even necessarily write the over 1. So you can look here and see that this equals 36, that equals 1, that equals 790. And I also kind of give us this question to kind of think about. Is 3 plus 5 the same thing as 5 over 1 plus 3? And you would say, well, hey, okay, I'm remembering back to that first lesson on addition. The commutative property says 5 over 1 plus 3 is the same thing as 3 plus 5 over 1. And if 3 plus 5 over 1 is just 5. So yes, these two things are the same, even though they may not look the same. And the fact that 5 over 1 is written as a fraction could suddenly seem really intimidating. We have to realize, yeah, these are still just the same thing. 5 over 1 is 5. So we're left with 3 plus 5 and 5 plus 3. And the commutative property says the order that we add doesn't matter. So yeah, these must be the same. Now the multiples property of fractions, and this is going to be sort of the backbone of a lot of what we're doing over the next couple days. And it's what we were talking about, that any multiple of b over b is just going to be that multiple, right? What's the second multiple of 3? Well, 3 times 2 is 6. So if I've got 2 times 3 over 3, then that's just going to equal 2, right? We're saying that there are 2, if we've subdivided this into thirds, and then we have 2 sets of 3, then that's just going to put us right at 2. We need to be able to kind of be flexible with this and recognize 20 over 4 can be written as 5 times 4, right? 5 times 4 is 20, so 20 is the same thing as 5 times 4. And then we say, hey, okay, so this fraction really just represents the fifth multiple of 4. So it must be 5. 20 over 4 on the number line is 5. And if we kind of jump back for a second, we can look at that series of number lines that we had drawn out for us. And see with fourths, if we count up 20 of them, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 would be 4, 17, 18, 19, 20. Hey, that's going to be over 5 on our number line. Okay, so moving on. So here's some problems to figure out. 3 times 7 over 7, what does that equal? Well, this just simply means the third multiple. We've got the third multiple of 7 over 7, so this must just be 3. And this must be 8, and this must be 1. Now we can expand these out, and this is where understanding our multiplication facts is really critical. 15, is that a multiple of 3? Well, yeah, it's 5 times 3. So this must simplify to just be 5. And 48 over 6, is this a multiple of 6? Is there some number times 6 that equals 48? Well, let's see. I'm not sure. Let's see. 5 times 6, that's 30. No, okay. What's 6? 6 times 6 is 36. 7 times 6, what's that? That's going to be 42. 8 times 6. Hey, 8 times 6 is 48. So this is 8 times 6 over 6. That means that this must equal 8. 5 times 7 is 35, so this is 5, and we can see on and on. Now here, 63 is, there's no multiple of 8 that's 63. So this is simply 63 eighths. There's no way to simplify that to a whole number. Same with 26 over 5. So anyways, we have our identity fraction, our identity property that says if it's over 1, it's just that number. We've got our multiples property, and if we have 1 times b over b, well, 1 times any number is just that number. So that'd be b over b must equal 1. And then we would do an activity in class. So that's a video on the introduction of fractions. I hope that was helpful. Thank you so much.